All right, so this was a a homework question from our implicit differentiation stuff. And I just want to be very straightforward with this. This is a pretty intense, like that's the reason I gave this one, pretty intense implicit differentiation type problem. So we have this equation there that you can see, and we were trying to find the slope at the point 1, 1. And again, this is pretty involved. So if we can do this successfully, then we've got this implicit differentiation stuff down pretty well. So I'm going to go ahead and get started. When I look at this equation that's on the left, I instantly kind of think about different options I have. So I know that what I'm really trying to do is I'm trying to find, slope, which is really dy dx. So what I know that I could do is I could just go ahead and take the derivative of this entire thing, or both sides, with respect to x, and that would work. I could try solving for y, but it looks really messy, and so I don't think that our conventional, easy way of doing it is going to work. So implicit's probably the best choice. Now, having said that, I still have options. So what I notice on the left hand side is that I have some group squared. Now, I could either use chain rule and then chain rule again inside of that, because y squared, y is actually a function of x, and so it's kind of some covered up function right there. That's a covered up function. So I could either use chain rule because I've got a group being squared, and then I'd have to use chain rule again inside of it because I have y being squared, but it's only a piece of it. Or I could just go ahead and distribute that out, x squared plus y squared squared, and that wouldn't be so bad. And then kind of forward thinking, I don't think it's going to cost me that much extra work. It might actually make it just a little cleaner. So I think I'm going to do that. And then things I want to make sure that I'm paying attention to are just structural issues, right? Like, so when I go to take the derivative on that right-hand side, I notice that it's a product, and maybe I'll get a brighter color. So I know that I'm probably going to have to use product rule there. So let's go ahead and just kind of execute what I was thinking. I'm going to stay with white because it's the original function. If I go ahead and I distribute out this thing, that group, I'm going to get x to the fourth, and I'm going to have plus 2x squared y squared, and then I'm going to have plus y to the fourth, and that's all going to be equal to 4x squared times y. And it doesn't look like I can clean anything else up from there, so I'm just going to go ahead and make little notes of structure. So I can see that I'm going to have to use a product rule there. See, I'm going to have to use a product rule here. And what I'm also going to kind of view this as being 4 multiplied by that thing and 2 multiplied by that term. That way I can just kind of leave my coefficients. So those structural things might help me. So then I'm going to go ahead and I'm just going to take the derivative with respect to x. Just go ahead and get that process started. And when I do that, let's see, I'm going to switch to pink since I'm now actually taking my derivative. I'm going to have 4x cubed. That makes sense. And I'm going to have plus 2. And it's going to be multiplied by, something. And so that something, I'm going to have 2x times y squared. And that's because I took the derivative of x squared multiplied by y squared. And then I'm going to have add, right, because I'm using the product rule, x squared. Now I take the derivative of y squared, right, which I know is going to be times 2y, because that's the derivative of the outer function. But again, I kind of want to look at the structure there. I can kind of see that's that chain rule piece. So I'm going to be multiplying it by, let's see, I took the derivative of y squared, the squaring part, and I need to take the derivative of the inner function, which is y. So I get dy dx. And again, I'm going to write that notation just because I want us to keep seeing it for a while. Although writing y prime would be completely fine. All right, so let's see. I took care of that product. Now I have to do, our y to the fourth, which again, right, we've got y, which is a function, and then we've got to the fourth. So I'm going to have to use the chain rule again. Notice how I ended my group there because that was that whole product. So plus 4y cubed, because that's the derivative of, y to the fourth or something to the fourth. And then I still have to take the derivative of the inner part, that y part, which is dy dx. And that's all going to be equal to, and let's see on the other side, I'm gonna leave that 4 again out front, and that way I can just leave it as a coefficient. And I know if I can go ahead and have 2x times y, right? Because that's that first part, derivative of x squared, times the second part, which is y, plus, because I'm using product rule again, x squared, right? Because I'm going to leave that one alone, times the derivative of y. Well, okay, that's just dy dx. Okay, wow. So that's a lot. So now I need to go ahead and I need to make sure that I just clean this up. So things I'm going to do, I'm going to go ahead and make some distributions, and then we'll go from there. So if I keep going, I'm going to have my 4x cubed here, and I'm going to have 4xy squared, and I'm going to have 2. Nope, I take that back because that 2 is going to come through, and then I'm going to have it multiplied by another 2, so 4x squared y times dy dx. All right, so now I've distributed that 2, plus 4y cubed dy dx equals, and if I distribute that 2, I'm going to have 8xy plus 4x squared dy dx. Now, what I already realized is this video is getting a little long, so I'm going to go ahead and pause it. And while I have this video paused, I'm going to collect all of my terms. So I'm running to isolate dy dx. So I'm going to collect all of the dy dx terms on one side and all of my terms that don't have dy dx on the other side. And I'm going to kind of show just what I'm doing a little bit. But I would encourage you right now to pause the video and maybe do this for yourself. That way you're just practicing some good algebra. All right, so you can see, right in this line, I went ahead and got rid of some terms on the left-hand side. And I felt like there was a lot going on, so I wanted to just show that separately. And then here I wrote down what I had left. And then you can see I went ahead and got rid of a term that was on the right-hand side. And so ultimately, this is where I'm at. You can see that I've isolated dy dx on my left-hand side and all my terms that don't involve dy dx on my right-hand side. So really quickly, I like to make things neater. I like to make things easier for myself. So something that I notice is that every single one of these terms really has a factor of 4 in it. So you could either think about dividing both sides by 4, or factoring the 4 out and then just kind of ignoring it. But ultimately what that's going to leave us with, I'll write it right here in pink again, is x squared y, plus y, forgot my dy dx, right there, plus y cubed dy dx, minus 4x, nope, not 4, right, minus x squared dy dx equals 2xy, subtract x squared, subtract xy squared. So just by getting rid of those 4s, it kind of makes it look a little bit cleaner. Now what I'm going to go ahead and do is I'm going to factor out dy dx because I see it's in 3 terms. It's in everything on the left. So I'm going to go ahead and factor that out so that I can kind of really get it isolated so it's only in one place. Now as I do that, I'm going to kind of clean out some space here in the upper left-hand side so you can see what's going on. So I'm going to go ahead and pause it, and I'm going to erase everything except for our final line right there, and then we'll just proceed from there. So at this point, you can see up here on the top left corner right there, all I've done is really kind of factored out dy dx. And as long as I transposed everything correctly on my screen, it should look pretty good. So keep in mind our goal here was to find dy dx right at the point 1, 1. So I just need to isolate dy dx. So I'm going to go ahead and divide both sides by this group right here. I'm just going to kind of write that down. I'm not even going to put it because that's just showing my work. So dy dx is going to be equal to 2xy subtract x squared subtract xy squared all over x that's an x squared y plus y cubed, subtract x squared. Now, what I have to understand is there's some common mistakes that students might start trying to like maybe cancel out that x squared. You can't. Just keep in mind that x squared in the denominator and subtract x squared is dividing everything in the numerator. Now, things you could do, we could actually clean this up a little bit. We could find common factors in the numerator and denominator. And I want to go ahead and speak to that. It's definitely doable. And if it's a ton of headache, I guess my question would be why? Because keep in mind, all we're trying to do is find the derivative at the point 1, 1. So ultimately, am I at a usable form of the derivative? And the answer is yes. So I could plug in 1 and 1, and it's not all that bad. Now, consequently, I could also factor out I see a value of x, and everything. It's a factor in all of the terms. So I could go ahead and get rid of that and clean it up. Maybe if I was looking for a more usable form in other problems. Now, I'm not here. So what I'll go ahead and do is I'm going to do this in two ways, and I'll just show my work. And again, I'm going to pause the video. But what I'll do right here is on one side, I'll just go ahead and plug in, I'm going to go ahead and plug in 1, 1, right? Because we just really wanted to find the value. And on this side, I'm going to try to simplify some first. Now, again, I would only do this if I needed to use it for another problem, but it's a good exercise in algebra. And I'll show all of my work as I do this. But again, if you want to do one of these, go ahead and pause your video because it's going to magically appear here in a second. All right. So evidence that mistakes happen. I was thinking I could actually factor an x out of every single term. And I overlooked that term down there in the middle. And so you can see over here when I went to do that work, I went ahead and I froze right there because I can't factor out an x. So I mean, I'm not going to say that this couldn't be simplified. I don't see it right away. And again, I don't think we need to, because you can see the work that I did over here in blue where I just plugged it in. So, sometimes that's going to happen, right? You have a thought and then you uncover that it's not going to work out, and that's okay. Either way, what we did find, and notice I used good notation over here, is we're saying that dy dx evaluated at the point 1, 1 is actually equal to 0. And that is the final answer. So what we found is really that the slope of that equation, that relation, right, at the point 1, 1 is actually 0. So it actually has a horizontal tangent line there. And that's what we were looking at. And that's what we were looking for. So I hope that this question helps. Definitely you can see a lot of my thinking as we work through it. And yeah, take care.